Hey yo, what's up, everyone? It's your boy, a J, a O, a A's, a B. Oh wait, whoa! It's your boy, a J, O, H, H, A, B, R, A, H, A, M. And we're back. We're back with the what the. We're back with the. We're back with math. We're back with math. 1 hour of math. That's how long I should do this. History set a timer for 15 minutes. So I got an idea on. Okay. Now I kinda got the idea on how to solve for the first question, or the first function on the first question. Can you let me know how to solve once again? Then I'll try solving them myself. Fast! Gotta prepare for the labs, yeah. I just want to make sure one thing. Okay, I was just making sure if the stream was muted or not. Okay. So we go through the steps cleanly. As you can follow the same structure, you will solve it yourself. The series is. So I did not do this one. Since the task asks for absolute convergence, the first thing is to consider for large K, the highest power dominates, so we compare the leading terms, numerator, denominator, thus the fraction behaves like this. Suggests comparing the series with P series, which converges because P equals. Where's my coffee? Okay, P equals. True. So k raised to 4. When you set the function limit to infinity... Oh, stop at the lights. Wait! I have an idea. It's like the best idea ever. Oh shit. Whoa, look at this book. I got it from the trash can. Okay, let me try this thing. So my idea was to put the laptop higher so I can add the keyboard under. What? Crack it up. I did not know you were that intelligent. I know, right? I know. Me too. I also did not realize I was that intelligent. Kinda little bit space, not a lot, but little bit space. And look at that. I'm now my camera is a bit towards straight. It's a bit straight now. It's okay. Good enough. It's good enough. Can I type on here? If I want, I can type. Ha 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 ha. Now, the ultimate question is: can I use my laptop tablet down here? Do we have enough space for that? Guess what? We have. Oh shit. Some rotation lock, okay. There we go. P equals 3 greater than 1. Oh, and BK equals, okay. Limit comparison test. Do we have that? Do we have a limit comparison test? We got harmonic series, Macpherson criterion, minor observation, root test, condensation test, Lebesgue criterion. Yeah, I know the quotient test. Okay. Before I start answering this, I'm gonna write the things involved in my in my notes. I have got I have written from the math lecture. So there were 5 tests for convergence. For convergence and Magarand criterion. I don't know if I got the spelling correct. Two, minor observation. 3, root test. 4, quotient test. 5, condensation test. 6, Leibniz criterion. So let me know which ones did you use to test in this example. Majorant, okay. Here the method used was majorant criterion. For comparison, we compare, okay, since we... Quotient rule or ratio test, okay. Okay. So the first one was majorant criterion, comparison between the average or rough value. So series behave similarly. Formally, this is done using limit comparison, which is essentially a version of the majorant comparison for this series. Majorant comparison, limit comparison, series 2. So you get the highest power value, yeah, and suggest comparing the series with P series, which converges because P equals 3 greater than 1. To justify this, formally we use a limit comparison test. So B of K, we compute the limit, substitute the expression, multiply, now we divide the numerator by K raised to 7. Why? Oh, to get rid of that, okay. So as K is infinity, we're getting 1 by 1. Okay, so since the limit is finite and non-zero, both series behave the same. Okay. Because 1 by K raised to 3 converges, the original series converges absolutely. If you want, I can show you the fast mental shortcut for recognizing this type of series immediately. Most professors expect the students to see it in 5 seconds. I mean, what when I see this, I need to know if that's like from this. I know it's 1 by k raised to 3. That would be the simplified form of uh, the series. Then you divide it. $15. Okay, I'll try writing this. Why did I use my laptop keyboard? I don't know. I just felt like. Oh shit. So the first question, the first function is using quotient rule test. No, what's the name? Limit comparison test. Okay, limit comparison test. So some of my doubts are, what is it called? So the series 2 uses quotient test where you first compute, or you just go for this one. K raised to 7 by, wait. Look at the structure. So as k becomes large, 5k, okay, and it goes to 0 very quickly. Bucket intuition. I don't need the bucket intuition. Formal test, what your professor expects. Use the ratio test. Let a of ak equals k raised to 7 by 5k compute. ak plus 1 by ak. K plus 1 raised to 7, 5k plus 1 times 5k, k raised to 7, k plus 1 raised to 7, k raised to 7 times 1 by 5. Now take the limit. So L equals 1 by 5. Since L is greater than 1, less than 1, the series converges absolutely. Fast intuition professors expect you to develop. If you see something like k raised to m by a k, where a is greater than 1, it always converges because exponential growth beats any polynomial. Exponential growth, yeah, okay. Example series that all converges, okay, if you want, okay. So I'm gonna write the question. Let's see how much I can remember. Let's start with 0. Not the screenshot, yep. Not that one. Yep, investigate the following infinite series. Let's keep it this way. Oh, shit. Let's keep it this way. Investigate. Hey Siri, set a timer for 15 minutes. For absolute convergence. So the first equation is k equals 0 to infinity, k raised to 7 by 5 raised to k. The second one would be infinity, sigma k equals 0 to infinity, k raised to 4 minus 2 by k raised to 7 plus 3 k cubed plus 8. Now, think. So we're starting with this one. Here, the function is in the form k equals 0 to infinity, k raised to x divided by a raised to k. Constant. Here, a raised to k, k raised to x, as, oh, I forgot the term, as exponents beats polynomial when it comes to values from 0 to infinity. Okay, so that's out of the way. Quotient rule or ratio test to prove if the function converges absolutely or not. So we consider So we consider the function a of k equals k raised to 7 divided by 5 raised to k, and a of k plus 1 equals k plus 1 raised to 7 divided by 5 raised to k plus 1. Limit k tends to infinity, a k plus 1 divided by a k. What do we do? What do we do? K plus 1 raised to 7 divided by 5, 5 raised to k plus 1 into 5 raised to k by k raised to 7. Now, how do we cancel this? I forgot. K plus 1 raised to 7. Wait. K plus 1 by k whole raised to 7 times 5k by 5k plus 1. I forgot how to solve this, not gonna lie. Let's do a common example. Let's take 2 raised to 2 divided by 2 raised to 2 plus 1. 2 raised to 2 by 2 raised to 3. So that should be cancel 1 by 2, right? So it's gonna be 1 by 5, okay. So 1 plus 1 by k raised to 7 times 1 by 5. What is that? So k tends to infinity, 1 by k equals 0. So fuck. Come on, kid, go for a bigger one. So it's gonna be L, and L less than 1 converges, greater than 1 diverges, equal to 1 inclusive or some shit. I don't know. So here we got 1 times 1 by 5 equals 1 by 5, less than 1 equal to L. Therefore, the series converges. Now, let's look at the next one. I'm a bit confused on the absolute convergence and normal convergence. K raised to 4 minus 2. K raised to 4 minus 2, k raised to 7 plus 3k. K raised to 7 minus... Not gonna lie, gang, I don't know if I could read the chat right now. But hey, we got a way. Fuck, it's reloading the chat. Ah! What's the other way to see if I could... Oh no, I'm not able to see the chat right now. Just a minute, okay? Just a minute. Plus 8. 3k squared plus 8. I'll close it. What was the chat? Guest 1337. Hey yo, what's up? What's up? Yo, hat is that freaky ass symbol. Are you talking about the Sigma? Sigma? You talking Sigma? You're talking about the ratio test. That was correct. Now the next one. That was the convergence test, right? Yeah. Series 1, major and criterion. Okay, okay. What? Comparison test or major and criterion. Okay. Uh-huh. So we do that. We just take an average. I'm a bit confused on what... I kind of know what this is. Like, we are rounding, but is there name for this thing? Ow. So we were doing the... Okay, what you're referring to is proper mathematical idea behind it. The common terms used are assigned topic, behavior, dominant term analysis. Okay, I think that's the word I'm gonna go for. Dominant term analysis. Dominant term. Dominant term comparison or dominant term analysis. We're gonna do a dominant term analysis, and from this we're gonna get the highest value, the value that is outputting the biggest numbers, or the exponent, or dominant value. What? Dominant term analysis. Dominant term analysis. So we compare it with... So it's a comparison test, right? Comparison test or majorant criterion. Okay, so we compare it with blah blah blah. Converges as and our series behaves similarly. The given series converges absolutely. Formally, this is done using limit comparison test, which is essentially a version of the majorant comparison. For this series, tests used majorant comparison, comparison, limit comparison. What? How were we comparing it? I forgot. For this, I'm done limit comparison, which is... Wait, we compare the limits. Do we divide it? Yeah, we divide both the functions, and we test the limit for it. So we give AK, BK, and we divide it. And if it's coming up to be 1, then that series converges, right? Yeah. Could you also explain this P series part? Mm-hmm. 15 minutes? Okay, come on, come on. Hey sir, set a timer for 15 minutes. What? Okay. A P-series is a specific type of infinite series. P is the constant number. These series have a very important rule called P-series test. The value of P, k raised to P. I'll just write that down. P-series test. This rule is standard result in analysis and used in constantly when testing convergence. Basically, it's 0 to infinity, 1 by kp, and p equals constant. P greater than 1 converges, P less than 1 diverges. Okay. Okay. I guess, bro. One by two is less than one, right? Or it should be greater than one. Okay. 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 So we have to do the P series test. Okay. Let me try answering this. So for this question, we're gonna find the dominant term slash exponent, which is infinity, k equals 0, k raised to 4 minus 2 by k raised to 7 minus 3k squared plus 8, k raised to 4 minus 2, approximately k raised to 4, and k raised to 7 minus 3k squared plus 8, approximately k raised to 7, which implies k raised to 4 by 7, 1 by k raised to 3, P series test, P equals 3, greater than 1, therefore converges. Putting this to the majorand conversion. It's not ratio test, comparison test. So what we're doing here is we're gonna take this value, a of k equals k raised to 4 minus 2 divided by k raised to 7 minus 3k squared plus 8, and b raised to k equals 1 by k cubed. The dominant term, now we're gonna limit k tends to infinity, ak by bk. K raised to 4 minus 2 divided by k raised to 7 minus 3k. 3k plus 8 into k cubed by 1. So k tends to infinity. Again, we're getting k raised to 7 by k raised to 7, 1. Which implies the series converges. But that feels so easy. I don't know. It feels. I feel like I'm not explaining enough. Let's see. Well, that's question number 2. So I have kinda answered both the functions, and from the looks of it, both converges, but I feel like I haven't explained them enough, and also I'm a bit confused on the absolute convergence and convergence. Does it matter, or they are just the same terms? They're not the same, although absolute convergence series is always also convergent. The distinction is important in analysis. Converges if the partial sums approaches a finite number. This converges absolute convergence. If convergence, in other words, you take the absolute value of every term and check convergence. Example, minus 1 raised to k. We take absolute values, so which converges if the original series converges absolutely. There are three possible cases. Absolute convergent converges, conditionally convergent converges, but okay. So when you take the absolute value, it diverges. Interesting. Divergent series does not converge. Okay. Examples of conditional convergence. The classic example. Minus 1 raised to k plus 1 by 1 by k. This converges, but Leibniz criterion 1 by k which diverges. So the series is conditionally convergent but not absolutely convergent. Okay. Your assignment specifically asked for absolute convergence. The instructions was investigate the series for absolute construction. So you must check using the limit comparison with P series whose exponent P, the series convergence, therefore the given series converges absolutely. Apply the quotient rule, test yield, hence the series converges absolutely. Okay. So P series test and quotient rule. Okay. Okay. Investigate for convergence. How is this one looking? Oh fuck. Okay. I'll give you. Wait. I got one more way to get the questions out of it. or give me the equations in the question or Excel sheet in a copyable form. Let me see if it's correct. Before you answer this second question, show me how you have interpreted the what? $15? Okay. Hey Siri, set a time before 15 minutes. So 3k plus 4. Oh, that's correct. That's correct. And no, that's correct. Okay, this one, I feel like this one might not converge absolutely because there's a -1. Maybe. 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 How long have I been streaming? Oh, how do I know that? YouTube. $53. Okay, okay. So let's do the next question. Whoa, it's slow. Why is it slow? Is it YouTube? Close, close, close. YouTube close. The job offer, okay. So series 1, 3k, 3 raised to k with k raised to 9. What we do here again, it's exponent. No, here the exponent is at the numerator, right? So I just know the first series just diverges, right? Yeah. So it's just diverging. So next one, 3 raised to okay. So okay. I don't think the 3 and 4 matters. So it's 1 by k. K raised to 1. Indefinite? No, I feel like that series, the second one, is converges. Does it converge when it's? I think it's absolute convergence. Yep. Okay. Let me wash my hands. I should get some water. Don't have a lot of time. Fuck. So, I'll start writing the next question. We're gonna share. It's taking a long time, but at least we're shared. So, second question. Investigate. Oh, it's not for absolute convergence. So, okay. Convergence. So we're going from k equals 1, infinity, 3 raised to k by k raised to 9. That's 1, that's 2. Sigma k equals 0, infinity, 3k raised to 7, 4k raised to 8 minus 1. The third question, sigma k equals 0, infinity, minus 1 raised to k, 1 by 7 raised to k. So, let's look into this. So far, if we're going for the first question, we got this. K equals 1, infinity, 3 raised to k by k raised to 9. Did I just rewrite that? Yeah, I did. The numerator is an exponent which is greater than the denominator, which is a polynomial? Wait, it's not a polynomial. Yeah, I guess. So from this, we know the series diverges. But if you have to prove that, show the proof. How do I do it? The ratio test. Okay, let's do the ratio test. Ratio test to prove it. So a raised to k, ak equals 3 raised to k by k raised to 9, and ak plus 1 equals 3 raised to k plus 1 by k plus 1 raised to 9. Limit k tends to infinity, and no, we're not testing absolute, right? So a raised to k plus 1 divided by a raised to k equals to L. So what was the rules? L less than 1 converges, L greater than 1 diverges. Con 3 raised to k plus 1 divided by k plus 1 raised to what? Raised to 9. Now divided by ak, so into k raised to 9 by 3 raised to k. So we're gonna get something like 3, right? 3 times 1, k by k cancels, plus k. So it's like 3 plus 3k. K tends to infinity. So this thing is greater than 1. Therefore, the series diverges. Point proven. I believe that's the answer. Let me see if I'm right. Now the second one. 3k raised to 7 by 4k raised to 8 minus 1. I need to write that. So, what are we doing here? I think we should find the dominant term. Find the dominant term slash exponent. So 3 raised to k7 divided by 4 raised to k8. So 3 by 4k. Does the 3 by 4 matter though? I don't know. I don't think so, right? It should not matter. Or does it? I don't know. From the P series test, P equals 1. Wait, what was the P series test? So p is greater than 1, p less than 1. So it's literally 1. Applying the ratio test to check if it converges or not. No, is it ratio test? It's not ratio test. It was a conversion test, right? To check if the if it converges or not. Converges or not. $15? Okay, I'll stop in a bit. So what's the convergence test? We got a of k equals 3k by 3k raised to 7 by 4k raised to 8 minus 1, and b of k equals 3 by 4k. Now limit k tends to infinity by a of k by b of k, which is 3k 7 by 4k raised to 8 minus 1 times 4k by 3. K infinity. So we got k by k equals 1. So we got 1 this time. This should mean the series converges. Okay, I'll do the third one later. Well, let me see if I got the answers right. Can I trust ChatGPT though to get these answers? Okay. I tried solving for series 1 and 2, and looks like I got diverging series for 1 and converging for 2. But for 2, I also got the P series test as 1. Usually it's greater than or less than 1. L equals 3. What? That's not what I got. I thought I got. Wait, we got. So k raised to 9 by k, okay? So KK got canceled, gets canceled. Then we got oh yeah, it kind of makes sense. It's one, so it's three. Which is also greater than one, so that's correct. So the series behaves like this is an harmonic series which diverges. So series 2 actually diverges, not converge. P equals 1, but the rule is... Oh, equal to. I did not see the equal to, bro. Come on now. Series diverges. Okay, I'll do the rest later. I'm gonna end the stream with the math, and I'm gonna eat something and continue with the lab journal. And also, I have some tasks to do. What are the tasks I have written down for myself? Prepare really good for lab, yeah. So before I stop, I need to send one email. Fast. So I got I forgot my Indian WhatsApp number, bro. Fuck. Where's my number? Yo, show me my number, dog. Me. Let me try saving this number. Oh, invite, no. Let's invite to WhatsApp so they don't have the number. Okay. I don't even know what number is that. Nope. Nope. You see, this not worky, it's no work. Okay. Well, I'm in the stream. I gotta eat something. We'll be right back. Peace out, gang.